everyone, I'm Shravanth Kumar. So the topic we are going to discuss today is crystal field theory. First is crystal field theory in an octahedral complex. So the points in crystal field, the concept of crystal field theory is it considers that the bond between CMA and the ligands in a complex is purely ionic.
What is CMA?
A central metal atom in an octahedral complex. And the attraction between them is electrostatic attraction. In an octahedral complex, the ligands are electron rich and the central metal atom is electron deficient. And the ligands and CMA are all point charges, so that makes them a charged species. While some ligands are neutral because they are electric dipoles. If they get polarized, they are charged species. If they are in a dipole state, they are neutral species. And before the approach of the ligand, the CMA is in an isolated state. That is, we can see that point here. This graph shows the splitting of octahedral complex. First is the degenerated orbital is in a ground state. That is before the approach of the ligand. And next, after the approach of the ligand.
What do you mean by orbital degeneracy? That is, they are maintaining the same energy, equal energy level.
Before the approach of the ligand. And then,
not only before the approach, even after the approach. But when it is much closer, then they split. So, stage A. What about stage A?
That is ground state of D orbital.
Degenerate orbital.
Degenerated orbital.
Degenerate orbital.
Then after the approach of the ligand, that is when the ligands get close enough, they get to excited state. That is the degenerate orbital gets to an excited state.
That is, all these degenerate orbitals are excited together. And what are those degenerate orbitals?
dxy, dyz, dxz, x square minus y square and dz square.
What is the nature of dxy, dyz and the dxz?
They are in between the axes.
They are distributed in between the axes, and they are called T2G, that is triplet. And what about the dx square minus y square and
They
dz
are
square?
along the axis and they are called EG, that is doublet.
Doublet.
Then when the ligand approaches the central metal atom in actual bond axis, that is when the ligands approach along the axis, the splitting of d orbital, that is degenerate orbital takes place, and the d orbitals that are along the axis, x square minus y square and dz square gets to an even more excited state, that is plus 3 by 5 del naught. Del naught is the crystal field splitting energy in octahedral complex. And d orbitals that are in between the axis, the spread in between the axis,
they occupy the lower energy.
Lower energy now. That is minus 2 by 5 del naught. The difference between Eg plus 3 by 5 del naught and T2G minus 2 by 5 del naught is given as del naught. Del naught is again nothing but crystal field splitting energy in an octahedral complex.
Actually, del naught is nothing but the difference between the Eg energy and the
T2G energy.
So this is 3 by 5 of del naught, and this is minus 2 by 5 del naught. So final energy minus initial energy. That is excited energy minus lower energy. So 3 by 5 minus 2 by 5.
3
so
by 5 plus 2 by 5, that gives 5 by 5, which is 1 del naught, that is just del naught. So that gets us over with the crystal field theory in octahedral complex. Now coming on to crystal field splitting in tetrahedral field. The difference between crystal field theory in octahedral and tetrahedral complexes, the ligand approaches in between the axes in tetrahedral splitting. That is the same thing. First, the d orbital is in
ground state.
Degenerate orbital is in ground state. The d orbitals are dxy, dyz, dxz, dx square minus y square and dz square.
Actually, there are 3 stages: stage A, stage B, stage C. Stage A is the before the approach of these ligands.
Ground state.
So ground state.
D is the excited state of
all
degenerate orbital. That is when the ligand comes close, and this is
much closer.
Much closer. Splitting of degenerate orbitals. Here, because due to that ligand is approaching in between the axis, the d orbitals spread out in between the axis. That is dxy and dyz, dxz gets to an excited state, even more excited state, and the d orbitals that are along the axis moves to a lower state, that is dx minus x square minus y square dz square.
So that is triplet is having higher energy than that of
doublets.
T2G is greater than EG.
EG. Yeah. So the T2G is given by 2 by 5 del T, and EG is given as minus 3 by 5 del T. The difference between these two is del T is equal to 4 by 9
del T. The difference is del T. And we are comparing the del T with the del O.
Yes.
So del T is equal to 4 by 9 times of del naught. That is crystal field splitting in tetrahedral complex is less than that of crystal field splitting in an octahedral complex. Del naught is crystal field splitting energy in octahedral complex, and del T is crystal field energy in tetrahedral complex. So these is the crystal field theory.
Okay. So what are the benefits of CFT?
That is, they help us to identify the color and magnetic property of these complexes. Well, that is impossible in DDT and Lorentz process.
And what is the T2G? T2G?
That is axis along
D orbitals are distributed in between
the axis.
Those are dxy, dyz, dx.
Yes,
And the EG means doublet, that is
degenerate orbitals along the axis.
okay.
Thank you, everyone.
Hey, don't talk.